Okay, hey guys, so in this lecture we'll be seeing the comparison of reversible isothermal and reversible adiabatic process. Let's get started. So we'll be seeing comparison of reversible isothermal and reversible adiabatic process. Okay. So isothermal processes, as we know that delta T in isothermal process is 0 or temperature is constant. So we can write that P1 V1 is equals to P2 V2. And what is adiabatic process? Adiabatic process is a process in which Q is 0, or in other words no exchange of heat energy takes place from system to surrounding or from surrounding to system. So we know that it can be written as P1 V1 to the power gamma can be written as P2 equals to P2 V2 to the power gamma. And if final volume are same, then we can write that P1 V1 equals to, let's say, P isothermal times V2, and again P1 V1 to the power gamma would be equals to P adiabatic times V2 to the power gamma. So if you take the ratio of V2 upon V1, so from this equation V2 upon V1 would be equals to P1 upon P isothermal, and from this equation we can write that V2 upon V1 to the power gamma would be equals to P1 upon P adiabatic. Okay, so some notes here that in gas expansion V2 is greater than V1 and gamma is greater than 1, so P1 upon P adiabatic would be greater than P1 upon P isothermal. We are just comparing the ratios here, so V2 upon V1 is the common part here, and as gamma is greater than 1, so this value would obviously be taken in exponential power, so this term would be more than this term. Okay, so in other words we can write that P isothermal would be greater than P adiabatic. Why? Because as this term is greater than this term, so we can write here that 1 upon P1 are common in both the cases, so 1 upon adiabatic, P adiabatic would be greater than 1 upon P isothermal. So from here we can deduce that P isothermal is greater than P adiabatic. So I was already writing it here. Okay, and the graph of the same will look like this. We have P and V graphs here. So let's say they start from point A and begin gas expansion. So isothermal would reach this point and adiabatic would go along this path or this trajectory. Okay, so in this point is P isothermal and this point is P adiabatic. Okay, the upper graph is or the upper curve is isotherm and the lower curve is adiabatic curve. Okay, and we already have mentioned that final volume are assumed to be same. Okay, so now next case is if final pressure are assumed to be same, or rather are given to be same. So if final pressure are same, okay, so again we have this curve or this graph between P and B. So final pressure are same, so this would be the curve for adiabatic process. From A point it goes to point B. Okay, and as final pressure are same, isotherm curve would be something like this. Okay, so this is isotherm curve. Okay, and this is adiabatic. So this is V adiabatic and this is V isotherm. Okay, so we can write that V isotherm would be greater than V adiabatic. Okay, so herein we can write from this graph that obviously the work done in isotherm was or in isothermal process would be greater than work done in adiabatic process, as the area under the curve is greater for isotherm. You can clearly see this, and the same is valid as well in case of let me not draw it, in case of adiabatic process as well, as the area under the curve of isotherm is greater than the area under the curve of adiabatic process. So herein as well I can write that work done in case of isothermal would be greater than work done in case of adiabatic. Okay, next, what happens in case of gas compression? In gas compression, so we have this graph PV. Okay, and in gas compression it goes from point A to let's say point B, and we are having that in both isothermal and adiabatic process final volume is let's say same. Okay, okay, so final volume is same, which is VF, and this is pressure of isotherm pre-iso, and this is P adia. Okay, and this is V final and this is V initial. Okay, so in this case you can see that in gas compression work done in case of isothermal is less than work done in case of adiabatic. Okay, isothermal. So this was the case when final volume was taken same. Let's see another case in which final pressure is considered same. In compression, again graph between P and V. So in this graph, final pressure is same of both the processes. One is adiabatic and another is isothermal. So in this case, as final pressure is same, so both the process start from point A, one goes to point B and another goes to point C. So pressure is same. Okay, and then this would be V iso and this would be V adia. Not exactly this. Let me make it more curly. So this is V adia. Okay, so I forgot to mention that this was adiabatic in the previous case and this was isotherm, and in this case this is adiabatic and this is isotherm. So again in this case we can see that V or W of adiabatic would be more than W of isotherm. Okay, hence in both the cases, whether in both the cases of compression, whether we are saying final volume is same or whether we are having final pressure as same, both the equations result in the same relationship between works, that is work of adiabatic process is greater than work done in isothermal process in gas compression. Okay, and how you can see that the area under the curve would be more than the area under the curve of adiabatic process would be more than area under the curve of isothermal process, and same goes for the gas compression in case the final volume of both the processes is taken same, that area under the curve of adiabatic is more than area under the curve of isotherm. So with this we come to the end of this lecture. In the next lecture we will be seeing cyclic process, and then we will be starting off on polytropic process. So till then, good luck and goodbye.